Hi, welcome back to the workshop. In today's video I'm going to walk you through how to set up and use a collet block assembly on a center lathe. This is a great way to add precision and flexibility to your tooling, especially if you're working with chucks, collets and small batch production. First up, we're mounting the collet block in a 4-jaw chuck. I'm using some simple magnetic aluminium jaw pads here. They may not win any beauty contests, but they get the job done. We'll start by indicating the ER50 socket taper to run true. For our first setup, we've got a 32mm ER50 Collet holding a quick change tool holder, which is clamping a 6mm keyless chuck. If precision matters, and let's be honest, it usually does, you'll want to dial in your part first. Later in the video, I'll show how repeatable this method really is. Now let's scale things up. Here we've got a 16mm keyless chuck with a number 3 Morse taper held in a 40mm ER50 Collet. If you're doing batch production, that toolless quick release is going to be your best friend. Not everything has to be keyless though. For parts up to 3/4 of an inch in diameter, you can use a traditional keyed drill chuck. This one's got a 25mm straight shank, and it fits neatly into a 25mm ER50 Collet. And let's be honest, sometimes that tiny chuck key is easier to deal with than trying to find the lathe chuck key you swear you just had 5 seconds ago. Now, the collet system isn't just about holding chucks. You can also feed long 40mm diameter parts straight through the collet block. I'm using a lapped bronze bush here for extra support. And if you're working with smaller parts, you can throw in an ER40 adapter inside the same 40mm ER50 Collet. Bonus, the smaller collet wrench is much easier to handle if you're working through multiple pieces. Need a 5C collet system? Easy. You can use that same 40mm ER50 collet to 5C adapter. In this demo, I'm mounting an 80mm 5C 3-jaw chuck. Great for clamping parts right in the bore with extra grip and precision. Here's an unusual one. External threading of small rods using the ER50 collet and a Morse taper adapter. We're holding a spring return, quick release tap or die holder. In this case, I've got a 4mm rod clamped in a keyless chuck in the tailstock and an M4 die in the headstock side. The setup makes threading multiple parts easy, and yes, it can be completely reversed if needed. Tired of fiddling with the 4-jaw chuck? Here's a slick alternative, a circular switchable magnet held in a 3-jaw chuck. This makes dialing in individual parts super easy. Just tap the piece and indicate. In this demo, I'm holding a 5C adapter inside a 40mm ER50 collet. A coin is clamped in a custom counterboard adapter with a depth stop collar, all held in a 30mm 5C collet. The next example uses a square 5C collet, and here's the neat bit. You can slide the whole unit off and carry on work on another machine by simply releasing the magnet. Repeatability and practical use. The big idea here is to indicate the part when it's loaded, instead of trusting the tolerance stack-up of multiple holders. Once the part is set, it stays set. I'll demonstrate just how repeatable this setup is with that 16mm keyless chuck in a moment. And before we wrap up, I'll briefly show how the sine function can be used in a milling vise. Here we've got a 40mm diameter bar resting nice and snug on both the front and rear vice jaws, positioned against an end stop. Looks simple, but we're setting this up with some precision. To level the bar to the collet chuck axis, we just need to calculate the correct gauge block height. And it's easy. Take the part radius, 20mm, and subtract the pin radius, 4mm. That gives us a gauge block height of 16mm. If you need 30-degree increments, just move the sine bar pins one hole over. Done. For anything in between, you can calculate the gauge block height using the built-in 90mm center distance sine function. So if you want something weird like 33.33 degrees, no problem. Just plug it into your calculator or use a sine table. And here's a tip. Once you've calculated the gauge block height, you've got options. You can stack the whole amount on one side or split the difference. Add half to one pin and subtract half from the other. It keeps everything balanced and makes the setup more stable. Collets and their accessories, some of the most underrated tools in the workshop. But when used right, they can save you from complex setups and custom fixtures, cutting down both time and effort. In this video, we're taking a closer look at two of the most popular styles, the 5C and the ER collets. We'll cover their strengths, their limitations, and most importantly, how to work smarter by designing around those limitations. Let's kick things off with the 5C collet blocks. They're incredibly versatile, but not without their drawbacks. One big issue, the clamping zone sticks out from the block, which means you can't use the end as a datum, and clamping over the ends, not an option. That really limits your setup flexibility. And then there's the stability problem. Because of the height to base ratio, they're just not safe to stand upright on a magnetic chuck for grinding. Now, let's talk about hexagonal collet blocks. You either clamp over the points or rest on them, neither of which is ideal. The solution? A 12-sided collet block. You get the advantages of both square and hex in one unit. I'm also designing this with full 360-degree indexing in 1-degree increments, thanks to an integrated sine bar. That means real precision, especially for angular work. Another major upgrade, you'll be able to clamp directly over the ends. That's a huge boost in versatility. And to avoid any interference, the collet nut will be smaller than the distance across the flats. It's a small change that makes a big difference. Now here's a common challenge. 5C collet stops float based on the part diameter. I've got a few solutions for that, which I'll show you later in the build. And yes, emergency soft collets will absolutely be supported. They're just too useful to leave out. At this point, you might be thinking, why not just use ER collets? Well, only 5C collets can securely hold very short parts. That's why we can't rely on ER alone. But we're not leaving them out either. The final system will support both, giving you the flexibility to handle odd sizes with ER and short lengths with 5C. Standard 5C collets handle short parts up to 30mm in diameter, but pass-through is limited to 25mm. The new system I'm designing, it'll handle long parts up to 40mm in diameter. Much more capability built right in. So there you have it, a smarter, more capable collet system designed to simplify your workflow and expand your options. Now let's get into the actual build process.